So today we will cover the pointing vector. Where this S represent the pointing vector, E represent the electric field, and H represent the magnetic field. Okay, so as you can see, it is the curl. Okay, so it is a vector product between the electric field and the magnetic field. So the pointing vector is what? The vector product between electric and magnetic field. So this pointing vector represent the directional energy flux or power flow of electromagnetic field. The scientist J.H. Poynting defined the pointing vector as you can see, it is the vector product of electric and magnetic field. So its units are watt per meter square, and the direction of vector product is perpendicular to the electric and magnetic field. So this pointing vector represent the directional energy flux or the power flow of an electromagnetic field, and it is named after the scientist John Poynting. Moreover, the heavy side also discovered independently in the more general form that recognize the freedom of adding the curl of an arbitrary vector. So as we know that the vector product is used when we are representing the perpendicular things. So here the direction of vector product is perpendicular to the electric and magnetic field. So the pointing vector is used throughout the electromagnetics in the conjunction with the Poynting theorem and the continuity equations which express the conservation of electromagnetic energy to calculate the power flow in the electromagnetic field. So it is defined as the cross product between electric and magnetic field. So in simple terms or in a plain language, we can say that the pointing vector depicts or tells the direction and the rate of transfer of energy, what we call as the power due to electromagnetic field. So in a region of space which may or may not be empty, so that depends. So it is the quantity which must be used to make a Poynting theorem valid. So Poynting theorem essentially says that the difference between electromagnetic energy entering a region and the electromagnetic energy leaving a region must be equal, and the energy converted or dissipated in that region is turned into a different form of energy, or many times it is in the form of heat energy. So if one accepts the validity of Poynting vector as a one of the tool to tell the electromagnetic energy transfer, then Poynting theorem is simply a statement of conservation of energy. So the relation between the electromagnetic field and the Poynting vector is that the Poynting vector represents the directional energy flux, or we call as the power flow of the electromagnetic field, and it is represented as the perpendicular direction both electric and magnetic field, and this what we call as the Poynting vector is perpendicular to both electric and magnetic field. So this was the analysis or the full introduction to the Poynting vector. Thank you.